Здравствуйте, меня зовут Матиас Сайдель, я являюсь директором по продаже компании Roth+Rau, которая входит в группу компании Meyer Burger. И я сегодня хочу немножко говорить о компании Roth+Rau, что мы сделаем, и хочу вам поближе объяснить, как энергоэффективность работает в реальном мире, дома у себя, и как мы можем это использовать в обыкновенной жизни. Мы очень рады здесь в этом проекте участвовать, и мы очень рады будем вашему участию в этом проекте тоже. Давайте нам вместе работать. Позвольте мне продолжать по-английски, потому что это мне легче будет, и я надеюсь, что это вам все понятно будет. Company Roth+Rau was founded in the year 1990, and it was a small company in a garage. And then it gradually grew. In the year 2002, we started to work in the photovoltaic business. And from that, the company saw a very bright and quick growth. In the year 2011, we were bought by the company group Meyer Burger from Switzerland. And since then, we work together with them to fill the full value chain of the photovoltaic industry. Meyer Burger is one of our largest shareholders, and we work together with them for a bright future. The company Meyer Burger is a globally operating company, and so is also Roth+Rau. We started our biggest operation in China, which is also our biggest market. Then we grew over to Taiwan, Korea. We now have offices in Singapore and also in the US. We're starting to develop our markets in South America and also in the Middle East area, where we think that photovoltaics has the potential to supply a lot of energy to people, to households, and to the industry. On this slide, you can see our top management. You can also see that Meyer Burger has the biggest share of our shares, and you can see that we have some minority shareholders. I would not like to bore you with all the figures, so I will go and start talking about technology, because that's what we want to focus on today, and this is what the main focal point is for us to have a good project of energy znania. In the Roth+Rau group, we have 4 segments that we basically work on. The first is photovoltaics, the second is microwave applications, the third one is installations and automations, and the fourth one is software. I would like to talk about a little bit about the first one, which is our core competence. It is coding. We do coding for all kinds of materials. Our main focus is on the photovoltaic industry, where we code surfaces with function layers like silicon nitride or aluminum oxide. We also do coatings for OLED. We do coatings for wear protection of metal parts and stuff like this. For this coding, and this is coming to the second segment that we're working on, we need the microwave technology. Back in the days when Roth+Rau was still a small company, we always needed to buy the equipment of microwave technology, because the core of what we do is PECVD, which is plasma enhanced chemical vapor deposition. So we deposit different materials out of the gaseous phase with the help of plasma. And for that we need microwave technologies, and one company, the company Mügge, supplied these, and in the course of our growth we had to acquire them in order to fulfill our production purposes. Installation and automation we do mainly for the semiconductor business, but also for photovoltaics. We help to optimize production systems from different fields of technology. And last but not least, software. We do our own software. We help for software with production equipment and also for PV installations, to help trackers and to help track the energy yield of a PV systems, for example. This slide shows just a few examples of our strong customer base that we have. I think there will be companies that you know, for example, Hyundai, for example, Bosch, or Zeiss. All of them use our equipment, and with all of them we have a close collaboration and work together. One of the main goals of the Meyer Burger Group is the focus on photovoltaics and the focus on the full production chain, starting from wafering, going over to cell and to module production. By doing this, we enable our customers to reach lowest cost of ownership. By engaging into the full production chain, we see where the connections, where the problems are to connect wafer to cell and cell to module, and to not lose a lot of energy in between them. It is most important to understand where we come from and where we're going to. We come from a piece of semiconductor material that is the basis material, which is silicon, and where we want to go is we want to have a module that is installed either on a roof or in a field that gives the energy that we need for our daily life. And this vision is the power that drives the people of Meyer Burger forward. This is the power that leads to innovation, and this is the power that helps us to find very tailored solutions for our customers that help them be productive in the future. In this slide, you can see the synergies of Meyer Burger. You see the different companies, you see the links that they have, you see that some companies are focused on specific topics, and you can also see that some companies have a broader variety, a broader spectrum of work, and that helps to link in the different sections to make a full production that is optimized and cost effective. Now I would come to the most important point, and which is also about what the Energieznanje project is doing, how to save energy in private households and in private installations. And here we have to see that there is different aspects, and while I go through the slides, I will explain, or I will try to explain to you what the key features are and what needs to be done to have innovation in the near future. Always, when you talk about innovation, you have to look where you come from. And in this slide, I would like to show a brief history of where we have been just 10 years ago, what innovation took us here, and where we can go in the near future. You see on the lower left side, you see a module of the year 2002, which was in the very early stages of photovoltaics. The cells used in this module had just an efficiency of 7 to 8%. They were really big, and the production was really expensive. And with 36 cells, which was a standard at that time, you could only make not even 100 watts per module. Then you can see in the middle that we have gone through some research and development, and we have come to a 60 cell module, which is the standard in the market right now, that uses monocrystalline cells with an efficiency of about 18.5% to produce modules that have an efficient, or that have an energy output of about 245 watts. We as Meyer Burger have developed a new technology which leaves the standard technology behind and goes the next step, which is called the heterojunction technology. It's a difficult word, but it's not so difficult. The only thing that is new is that it uses a broader spectrum of the light. And also, with different films that we apply, we are able to use, even when there's low light, meaning a cloudy day, we can use the energy and have a broader and higher energy output of the module. And you can see that with this technology on the right-hand side, we can produce over 300 watts per module using 60 cells. The efficiency of each cell is a little bit above 21.5%. In this slide, we see the usual German PV installation. You have the solar modules, they're brought together in a connector, then you go to the inverter to go from direct to alternating current, and then you feed it into the grid. And then you see the other side, it's on the left side, you have another electrical meter that takes the energy from the grid and feeds it to the end user in your household, meaning washing machines, dishwashers, light, TV, computer. And this installation type has brought one or two side problems with it that we have to tackle and that I would like you to think about. One of the problems is that on a very sunny day, a lot of energy is fed into the grid. And that means that other energies have to cut back, like coal, like oil, like other energy sources. Here you can see the usual connection of a photovoltaic system to the grid and to the household. You can see that the connection to the grid is done by an electrical meter that is only counting the energy that comes from the system that goes into the grid. The photovoltaic panels are connected to an inverter, which translates from direct to alternating current, which is the current of our grid. And then you can see on the other side that there is the connection to the household, which is an electrical meter that counts how much energy you take out of the grid and then feeds it to the end users in your household. Washing machine, dishwasher, computer, or television. And you can see that actually you have two circuits. One circuit is the energy creation feeding to the grid, and the second circuit is the energy flowing from the grid, from the outside world, to your end users. And this has been done for many years because the system in Germany was set up like this. It was wanted from the government to be like this. All energy that is created goes to the grid and is taken from the grid. Now here we have the same picture, but I have encircled the inverter and the electrical meter. This is something that we need to change. This is something that needs to be done different. Because, first of all, it is important to feed the energy to your own house. And only what's left over needs to go to the grid. By doing this, we have a very, very big upside. And that is, on a sunny day, you use the energy in your house and feed only that which is left over to the grid. And this means less energy goes to the grid, and this means that the energy is used at the place where it's supposed to be used and is not attached to the losses that a grid naturally brings. So by doing this, we have one big advantage. We use the energy at the place where we need to have it. Generation and usage is at the same place, and that saves us some losses. Now when we do this, we do the change from, we take the energy only from the grid. We need to change our mindset. And this is something that also has to do with innovation. It's not only that we need innovation in technology, but we also need innovation in the way how we think, in the way we do things, and in the way we look at things. And once you have the ability to use the energy where it's created, you need to use it when it's created. Now in photovoltaics, it's pretty easy to understand. The sun is shining, that's when you have energy. Most of the features that you have in your house, like a dishwasher, like a washing machine, stuff like you see in the slide, they have one feature that is very seldomly used, but every machine has it. It's the timer. Now when you want to wash You usually go to the washing machine and you switch it on whenever you want. This is very convenient. True. But if you go one step ahead and you say, I can wash my laundry even when I'm not at home, when the sun is shining, maybe you're at work, the sun is shining, then you can use the energy that is created right at the moment that it is created. The only thing that you need to do is, in the morning when you leave the house, switch the thing on and put it on timer. And it will do the job while you're gone. One other aspect of energy saving is that we need to keep thinking positive. We need to keep thinking innovation. Now I know in the past years in Russia you have made a big step ahead. Your president announced just a few years ago that all conventional light bulbs will go away and they will be replaced by energy-saving light bulbs. This is a very good step, and I really commend your country for doing that, because everywhere I go I see energy-saving light bulbs. But then eventually you have to take the next step, and the next step is that you go from these energy-saving light bulbs to LED light bulbs. At the moment, they're still very expensive. They're not commercially fully available wherever you want them. But I see during my travels that there is companies in Russia and in other eastern states that start to make those LED light bulbs. And eventually, with everything, once there is a big market, things will become cheaper. And what we see in the energy consumption of a normal light bulb to a energy-saving light bulb is we saved about 40% of the energy. Maybe in some cases even more. But if we take the step from the energy-saving light bulb to the LED light bulb, we can again cut the energy demand almost by half. It will depend on how much energy you use and what the application is for. But keep in mind, once you do a correct thing, do it and take the next step. In the previous slides, I have talked a lot about energy saving and about energy that comes from the sun. But this is only one aspect of energy saving in a household. The other big aspect is heating and water heating. Everybody wants to go in the shower in the morning and have warm water. And if possible, go into the bathroom and have a very warm feeling inside. For that, we need energy. Here in this field, there's also the possibility to save energy. And it's relatively easy to upgrade in houses and to fill in new. These technologies are called floor or wall heating. You can see in the pictures in the slide one example for floor and one example for wall heating. The beauty of this system is that the inlet temperature can be reduced almost by half. In conventional system, like my own home, I have used an inlet temperature of about 70 to 75 degrees Celsius. With this system, you achieve the same heat, but the inlet temperature is decreased to maybe 35 to 40 degrees. And by doing that, you can calculate how much the amount of water is in your system and how much you save by not making a lift from 8 degrees as it comes out of the public grid and to lift it to 40 or to lift it to 70 degrees. By doing this, energy is saved by keeping the same standard that we have at home. These systems have another beauty. You don't need to change your heating system. If you have gas heating, if you have oil heating, or if you use solid fuels, you can still use them, but they will only be using the fuel more efficient. And this is a way how to save energy. One other field of innovation goes into the well-known topic of heat pumps. Heat pumps basically use the same method as a refrigerator, but only turn it around. They use the energy of the surrounding, compromise it, and pump it into your house. This technology is available in the market, but is still an expensive technology. We see the prices are going down and it becomes affordable for more and more people. These heating systems require, in most cases, floor or wall heating because they are sized to only make a lift to about 50 degrees, 50 or 55 degrees, which is the normal temperature of the water that you will shower with. I hope with this very brief presentation, I was able to catch your focus on energy saving and on the huge potential we have to save it. One of my greatest motivation are my kids. I want my kids to have a future that is as good as I have it, or maybe even better. And for doing that, we must think about using our energy sources economically, and we have to save so they have the same possibilities as we do. Let me give you 3 points on your way of thinking, of creating new technologies, of thinking about innovations that nobody has thought about. Point number 1 is, every household is different. Think of it differently. By saying that, I mean the following. Sometimes it is easy to put the big coat of technology over a broad variety. In the case of energy saving, we have to look at each project separately, because each project, each household, each factory, each microrayon may need their own tailored solution. We have seen in the past that if an energy saving method, wrongly applied, wrongly calculated, and wrongly implemented, can do more harm than it can do good. So please look at each project separately and size and make your calculations for each project. This leads me directly to point number 2. Only if it's done correctly, it will lead to good results. In the past in Germany, we have seen that the growth in photovoltaics was so rapid that no one could keep up with this progress. And some systems were installed with the wrong calculation. And friends of mine were really becoming angry at photovoltaics because it was not giving the results it should, because it was sized in the wrong way. So please, make calculations, look at it, and only if you're sure, put it to implementation. And point number 3, look at it from a very different angle. In photovoltaics or renewable energies, we do not have a problem of day and night, but of winter and summer. Спасибо вам большое за то, что вы смотрели. Я очень рад с вами участвовать в этом проекте и желаю вам успехов.